Good evening, ladies and gentlemen. My name is Joseph Austin Farrar, and I'm participating in the Challenge Program 2016. Today we're going to be talking about one of my favorite French people. Give me a second to pronounce his name. Guillaume Francois Antoine Marquis de l'Hôpital, otherwise known as L'Hôpital. Now, a little bit of a background about this guy. He was a two-time vice president of the French Academy of Sciences. He was mentored by a mathematics person named Johann Bernoulli, and he wrote a book called Analytic Treatise on Conic Sections. And most importantly, what we're going to be focusing on today is his famous rule known as L'Hôpital's rule. Now, here's the problem we were given in the placement exam. We were given limit as x approaches 1, and the function on top was 1 minus x times cosine of pi over 2 times x. On the bottom, we had ln x plus 1 minus x. Now, my teacher always said whenever you run into these kind of limit x approaching something problems, the first thing you have to do is plug in the 1 and see what happens. So, as you can see what I did up here, I plugged in the 1 in all the spots I saw in x, and boom, we got 0 over 0. And this is where L'Hôpital would be like, aha, we must use L'Hôpital's rule. Now, that's the most important indicator of L'Hôpital's rule. Whenever you get 0 over 0, you must, no exception, use L'Hôpital's rule. And just a little backtracking to limit my x approaches 1. Again, the whole point is to find the y value the graph is approaching as the x value approaches 1. Just a little bit of background on that. Now, as I said before, 0 over 0 is a huge indicator of using L'Hôpital's rule. Very important to remember that. That's the key point in this lesson. Don't forget L'Hôpital's rule. Now, L'Hôpital's rule, let me give a second to explain that. In L'Hôpital's rule, what you have to do is you have to take the derivative of both the upper function and the lower function independently. Meaning you take the function on top, take the derivative like you normally would, then take the function that was on the bottom, and take the derivative of that function as you normally would. And if you did that, you would get this. So you get 1 minus x times negative sine pi over 2x times pi over 2, added to cosine of pi over 2x times negative 1. A little bit of a side note on that. Don't forget in here you also have a chain rule within your product rule. So don't forget that. That's a huge no-no in the math world. And on the bottom here, again, this is the derivative of ln x. Alright, moving on. They do the same thing here again. You plug in 1 wherever you see an x, which is what I did down here, as you can see. And look what we got, guys. We have 0 over 0 again. Now, some of you might be thinking, I give up on calculus. I'm never doing calculus again. It's wrong. L'Hôpital was wrong. I give up. But no. Just do it again. You do L'Hôpital's rule again. Now, it's kind of a long, nasty function at this point. But you do eventually get this answer. And when you get this answer, then you're excited. Because you use L'Hôpital's rule 2 times to be able to get to this answer. Now, there's something else you can also do here to kind of verify your work and make sure you're doing the right thing. I'm going to show you that on my calculator real quick. Now, I'm working with a TI-84 plus C color edition. And what I did here, I'll show you my Y values menu. I put the top function, again, this is the original function, the top one I put in my Y1. And the bottom one, I put in my Y2. And then my Y3, I made the top divided by the bottom, just like it was on the paper. And so I'm going to put that, press graph, and I'm getting this function here. Now you can see, I'm sure it's close up to the camera, you can see that. You can see it does approach a value as you get closer to 1. So what you do is you go to your table, so that's second table for your TI-84 people. And you plug in 1, and lo and behold, what do we got? Negative 3.142. Just like I got here. So again, that is L'Hôpital's rule. Very important to remember. Don't forget it, and don't forget to be awesome. Have a great night.